So we're going to do some introduction to a new coordinate system. It's called polar coordinates. What we normally work in are called rectangular coordinates, or sometimes you'll see the word Cartesian coordinates. Rectangular or Cartesian coordinates, that's what we're used to graphing. When we think of a graph, we think of x, y normally. So those are rectangular coordinates. We can define points on a graph differently, and the way we do it with polar is we use distance and direction. We use a distance and we use a direction. That's not direction. That's direction. There we go. Okay, so the distance, what we're going to do is always going to measure from the origin. We're going to measure from 0, and we're going to measure the distance. We call that distance r because it's the radius of a circle. So r is how far away the point P is from 0. So the distance will be determined by the radius of a circle, and then the direction is right here. That's the angle from the polar axis. So if you're thinking on a unit circle, this is an angle measure, and this is your radius. This will oftentimes be in radians, but the ordered pair will be written as r theta. You will have the radius of the circle, and you will have theta, which is the measure of the angle. If you guys remember, we did Battleship, and Battleship was using polar coordinates. So when you see this, it should be something that kind of strikes you as familiar, even though it's something we've never studied. We've seen this idea before. So if I tell you to plot the point 1, 3 pi over 4, what 1 is telling you to do is, I want you to be a distance of 1 from the origin. So this circle is a distance of 1 from the origin. So we're somewhere on this circle. That's what the 1 tells you. And then 3 pi over 4 tells you the angle. So if this is 0, this would be pi over 2, 3 pi over 4 is right there. So that's point A. I'll graph the other ones, and then we'll talk about different representations. Point B is 3, so that's 1, that's radius 1, this is radius 2, this is radius 3, so we're on this circle somewhere, radius 3, and then negative pi over 6 is right here, so that would be point B. Point C is 3, 1, 2, 3, and then 3 pi, so this would be 2 pi, and then I go around again, now I'm at 3 pi, that's point C. And then point D is negative 4 pi over 4, so when you see a negative radius, this is kind of a weird thing. Pi over 4 is this line right here. I'm going to actually draw this line all the way through, because what this is kind of doing is it's saying, look, if I went out 4, 1, 2, 3, 4, that would be point D if this was positive 4. But since it's negative 4, it's like saying, okay, 4, 3, 2, 1, 0, 1, 2, 3, 4, that's actually point D. It's negative 4, because it's like saying, if I was going to measure out in the positive direction, go that way, but since I'm measuring in the negative direction, you use pi over 4 to help you, but you're actually going to go over here to 5 pi over 4, and that's D. So we can use this idea of the unit circle to write these in different ways, and there's a bunch of different combinations. I probably won't list them all. Like 1, 3 pi over 4. I could say, that's the same as 1, negative 5 pi over 4. Negative 5 pi over 4 is the same angle, it's just I'm going clockwise instead of counterclockwise. Or, if I wanted to try and make the radius negative, I'd say, okay, that would be the radius being negative, so we'll say it's negative 1, and then the angle would then be, if I wanted to be up here, I need to think, well, this would put me at negative pi over 4. So if I went to negative pi over 4 and then I took the radius as negative 1, I'd say go to negative pi over 4 and then go through the origin with a radius of 1, and you're at the same place. So you can check the key for a couple more of these. I'll maybe do part B, but I'm not going to do all of them. So part B, let's try another one. I could say that that is radius 3, and then you just go all the way around, so that's the same as 11 pi over 6. Or I could say it's negative 3, and then where would I be? Negative 3 would be at 5 pi over 6. So check the answers that I posted to see all of them, but the idea is going to be the same. It's just like on the unit circle, there's lots of co-terminal points. We could write these things different ways. Okay, so the other thing you might want to do is you might want to convert a point that's written in polar into a rectangular coordinate. So this has everything that we would need. We have x, y, and r, so it's both the Cartesian coordinates and the polar coordinates on one graph. If I said write x in terms of r and theta, we're just doing some trig here. We're using a trig function. X, r, and theta, that would be adjacent hypotenuse, so I'd say the cosine of theta is x over r, so that means that x is, if you multiply both sides by r cosine theta. And similarly, the sine of theta is y over r, so y would be r sine theta. Now we'll do some more conversions later, but this is where it's all stemming from. Let's actually just do some where we don't really need those formulas. So here it says find the rectangular coordinates for the point that has polar coordinates. Okay, so polar, we got to think of first where would this be. So 4, 2 pi over 3. The radius is 4, and 2 pi over 3 is up here. So 2 pi over 3 is the angle, and the radius is 4. So that's telling you the hypotenuse. If it's 2 pi over 3, this is a 60-degree reference angle, and I remember my 30, 60, 90 triangle as 2, radical 3, and 1. So if you tell me that the hypotenuse is 4, then I'm going to say this is half of that. This is 2, and this would be 2 radical, that should be a 3, 2 radical 3. So we have 4, 2, because it's half, and then 2 radical 3. So the coordinates in rectangular form, the x-coordinate would be -2, and the y-coordinate would be 2 radical 3. So these are the rectangular coordinates for that polar point. Let's do one more like that. Let's graph it in rectangular coordinates. So if we graph it in rectangular, we're going to be down here. 2, -2 is something like that. I know that this is 2, and I know that this is -2. And this is the side of a 45, 45, 90, so that's another special right. I remember it like that, 1, 1, radical 2, so if it's 2, 2, it'll be 2 radical 2. So if this is a 45, 45, 90, then I can say, okay, I know the radius of this, the distance from here is 2 radical 2, and theta, you could say negative pi over 4, that would work, or you could say 7 pi over 4, that'd be the same thing. Both of those would be completely acceptable, and we have, I like to keep the radius positive, so I probably leave like that. So that's sort of an intro to polar. If you want to give some of these problems a shot, probably a good idea. We're going to go over all of this again when I see you next time. So I hope you guys do well, and I'll see you when I see you.